Question 1, electrostatic swing. Sean is helping his physics teacher at the school open day. He connects two vertical metal plates to a Van de Graaff generator. The metal plates are shown on the picture below, 12 centimeters apart. It's probably important. My line's kind of thick. Yeah, we'll change it. The diagram on the right represents the electric field between the plates when the high voltage supply is turned on. It says A, state which plate A will be as positive and give a reason for your answer. Okay, if you, with the direction of the arrow is that way, a positive test charge would go that way. That means this side is negative and this side is positive. A is positive. And the reason for your answer is because the field lines travel in the direction of a positive charge and opposite charges repel. So field lines, direction, and opposite charges repel. There we go. And so a positive charge goes in. Anyway, you get the idea. B, state how the diagram shows the electric field between the plates is uniform. They're even spacing. Okay, so if you go back up to the diagram, have a quick look. They're very evenly spaced apart. That means they're uniform. When they're spreading out, it's non-uniform, or converging. They're non-uniform. See, the strength of the electric field between the plates is this. That's E, with a wiggly line underneath to show that it's a vector field. Show that the voltage produced by the Van de Graaff generator is 400 kilovolts. Remember, with a show question, you can ignore the answer until you check it at the end. So the electric field strength is the voltage divided by the distance. We have the electric field. We have the distance of separation. I think it was 12 centimeters, which is 0.12 meters. So we're trying to find V. So V equals ED, which equals this times by 0.12, and that should give you your 400. Next, Sean has a metal ball with a mass of 2.5 times 10 to the minus 2 kilograms suspended from a long thread. He puts the metal ball between the plates. It touches the positive plate and gains a positive charge of 1.5 times 10 to the minus 10 coulombs. Calculate the speed of the ball just before it hits the negative plate. Now, this could be a tricky one, but usually you're dealing with kinetic energy. So you have electric potential energy, which goes to kinetic energy, and you just calculate out those parts. So a good way of looking at this is to look at the work done to move the ball or to accelerate the ball between the plates, and that work done will equal the kinetic energy, which equals half mv squared. So we've got the mass there, and the work done is the force times by the distance. The distance we have is 12 centimeters, 0.12 meters, and the force, remember, equals electric field strength times by the charge. We have the electric field strength and we have the charge over there. So it's just a matter of plugging all of those in. So it's three equations. That's why there's so much space to use this, and that's why it's an excellent question. Please excuse my sniffing as well. It was a very damp ride in this morning. So what does that look like if we're working it completely through? Well, we've already said we're aiming for the kinetic energy, so half mv squared is going to be one part of the equation. That equals the work done, which equals the force times the distance, which equals E times Q, which is the force, times the distance, EQD, and E is the electric field strength, so I need a wiggly line under that. And you'll rearrange to make V the subject and substitute all of those things in that we know to find V. That's how you would work that one out. The last one. C. Describe the motion of the ball after it touches the negative plate. Now this is a cool question, because remember, it's on this side, it's had the positive plate, and the ball has now become positively charged, and it'll experience a force which is going to bring it across in a slight, it's a pendulum, but it's so close you could consider it a straight line, I think. That would be a reasonable assumption. It's going to experience a force that way, which is going to accelerate it that way. It's going to hit this plate, and then it's going to become negatively charged, because all those electrons that are on here are going to balance itself out by rushing on to balance out the positive charge that was already on it, and now you're going to have a negatively charged, which is going to experience a force this direction, and it's going to go back across till it hits and it becomes positive, then it's going to go back across till it hits, becomes negative, and it's just going to keep going back and forward. Really cool. And because you've got the Van de Graaff generator continually running, this motion is perpetual within that system. So it might actually run down eventually if there was nothing to replenish the charge, as the ball gradually evens the charges out, but it's basically non-stop.